So welcome for our breakout session of Tulip's help on 8-bit's path to digitalization. The room is sponsored by Keeney, Donovan, and McKee, or as we call them, KDM. My name is Richard Goyette. I'm a smart manufacturing project manager, which means that I help small, medium-sized companies to integrate technology and figure out what technology is going to help them to achieve their strategic goals. I work for Mass MEP. MEP overall is a federal program to help manufacturing companies to grow. They're all 51 states, including Puerto Rico, have at least one MEP center. That being said, there are two things that we would like from you or that we need from you. One, at the end of the day, if you could fill out the survey to let us know how we can improve and how we can get better doing this and delivering this for you. And the second thing is that since we are run by run through NIST, you will be receiving a survey about 6 to 12 months from now through a third party, and that's how NIST evaluates how we're doing and helping your companies to grow. So the questions will be around how this information helped you to improve. That you do not have to do by yourself. One of our business development advisors will contact you and help you to work through it, because it is a government survey, so it can be a little questionable on what it actually means and what they're trying to ask you out of it. But that'll be in about 6 to 12 months, just long enough for everybody to forget everything that they did. But so I will hand it over now to our speakers. They can tell you a little bit about themselves.
Thank you for kicking us off. I'll go ahead and introduce myself. My name is Madilynn, but everyone calls me Maddie, and I hope you all do as well. I'm the head of marketing of Tulip Interfaces, which is a global software company headquartered in Boston. We're actually in Assembly Row, so we're bringing manufacturing back to Assembly Square, which, if you've been there, is much more medtech and shopping center than it had been when it was a Ford assembly plant. But we also have offices in Munich and in Budapest, and customers really all over the world. So Tulip's a frontline operations software, which is a no-code platform built for operational environments, particularly manufacturing. And what that means is that rather than just being a place that you can make like no-code apps, we're built with that frontline engineer, process engineer, manufacturing engineer in mind. So we are GXP ready. We have those connections to machine protocols and devices built into the platform. We support no-code computer vision, we support generative AI copilots. All of the data is collected in there automatically, and it runs on different interfaces. So whether that is a computer or a machine terminal or a mobile device or a wearable, the Tulip apps can live in those different places, all no code. So we're bringing that powerful technology to the domain expert, which is that manufacturing or process engineer. And we work with a variety of different companies. We work with cool startups like Inkbit, and large global companies like Stanley Black & Decker and D&G Mori, and some of your favorite pharmaceutical companies like Johnson & Johnson. So that's as much as I'll say about the Tulip as a big overview for company. I'm really pleased to be able to introduce or have Filip introduce himself and share more about his journey at Inkbit.
Thank you, Maddie. Hi everyone, my name is Filip Losowski. I'm head of operations at Inkbit, a cool startup company. We are a 3D printer manufacturer, actually out of Medford, Massachusetts, so we're fairly local. I am actually not from 3D printing. I spent the bulk of my career in more traditional manufacturing, so metal cutting. I worked at a company called Supfina Machine Company out of Rhode Island. So we were a equipment manufacturer, machine tool manufacturer. And about 3 years ago is when I made the change and moved up here and started at Inkbit. So Inkbit is actually I guess you could think about it as 3 different businesses in one. So we are a machine tool manufacturer. We design and build and sell industrial production scale 3D printers. We're also a chemical manufacturer, so we synthesize and manufacture our own resins. And also we run a service bureau. So sort of a customer has a part file or something that they need printed. They don't have money for a machine, so they send us the part file and we print it for them and get paid. So a lot of complexities associated with that, a lot of different operational challenges, which we'll go through. But a little bit more about kind of our tech, I guess. We utilize what's called vision control jetting. So essentially the brain of our printer is what we call the scanner. And it's a series of cameras and lasers and a software algorithm that reads the surface of a part. So our print, our build area is actually in the middle of that table there. That's a full build volume for us. All the parts that are associated with that build are put together in our construct software. It's actually Andre said it best, but I'm gonna, I'll try to say it. But essentially, in our quest to be able to create a software that very efficiently packs all the different parts together to make it an efficient print, we've inadvertently created probably the most efficient packing software known. And we're also engaging with companies on potentially just utilizing our software for packing and nothing to do with 3D printing. Pretty cool. So we stumbled into some revenue there, which is fantastic. But anyway, so we set up our prints using our construct software, send it off to our printer, which is additive manufacturing process that we've developed. Traditional manufacturing, you oftentimes have a roller or something to be able to flatten a surface to create a nice, even and accurate surface for the next layer that's going to be deposited in the 3D printing process. We don't do that. We use vision to be able to read the surface for each layer and then adjust accordingly for the next one. So very, very accurate deposition of materials for each layer of the printing process, which means we get very, very high accuracy parts, at least more accurate than what a lot of companies can achieve today. And then once the printing process is done, it goes to our post-processing, so the parts have to be cleaned after they're printed. We've made some strides there as well. So we actually print not with kind of support structures as you normally see in 3D printing. There's structures that are printed out to support the part during the 3D printing process. We print with wax and resin. So wax is used kind of like a concrete form. So we'll print wax and then deposit the resin within there. Then once the print is done, it's encased in wax. We melt the wax away and the parts are parts. They're ready to go. Almost ready to go. We have to just clean them off, essentially get the oils and things like that off the surface of the parts. But there's no cutting, there's no trimming, there's no sanding or any of that sort of stuff. So that's another area that we've kind of changed, I guess. A little bit more about our vision control jetting process. We're essentially an inkjet process. So we use, it's our own resins, but inkjet resins. We deposit those utilizing inkjet printheads. They're industrially, commercially available. And that in conjunction, the high DPI of those printheads in conjunction with our scanner is able to reach, accuracies that, it depends on feature, depends on part size and all that sort of stuff. But I come from metal cutting. I'm used to sub-micron accuracy in a super finishing machine. Here we're talking, maybe 20 micron, depending on the feature or whatever. So very high accuracy process, at least when it comes to the plastics. So that got me pretty excited about all this. But also when it comes to kind of what we can do, and I talked about being part dependent, it's also application dependent. So I think on the next slide, we are in a few different spaces. So at least as far as pharma and medical goes, we have a chemical resistant epoxy that we've developed. And it actually works very nicely with respect to fluidics and very, very tiny channels for moving different medicines or whatever pharma companies do. They need certain very kind of high tolerance manifolds. So that our accuracy in conjunction with our chem-resistant epoxy allows us to enter into that space. Automotive and industrial, door gaskets, underhood components, things like that, seals for like if you have an electrical connector and you need that kind of like a rubberized seal where it might move or flex or something like that. You need it to be waterproof. Robotics and automation. We had a Nature paper actually released somewhat recently in the last year or so, where and it's actually on our design guide there on the left-hand side of the table. that robotic arm, fully articulating, soft and hard components, all that sort of stuff, was printed all in one go. Ready to be put on a robot, and utilizing air can articulate and grab and move and do all sorts of stuff, which is very exciting because that means we are also printing multi-materials. So not one type of plastic at a given time, but kind of like our build shows over there, different types of resins in a single build all at the same time. Consumer as well, so overmolding. Andre was having some conversations with some folks prior to this starting up, but overmolding is also a pretty popular space. Hard plastics, prototyping, whatever. Overmold, maybe a soft rubberized handle or something. You'll see some parts on the table over there that kind of visualize that. Yeah, so a lot of different spaces that we can enter. In fact, we're currently digging through to determine what the appropriate kind of revenue paths we want to take, where are the most, I guess, appropriate revenue streams for us, where do we pursue, what is the product market fit. That we're in this phase of when we say startup. We've developed the technology, now it's time to start commercializing, go to market. Yeah, we did have a video, that's right. And this is not of the printing process itself, but as soon as the part's finished. So these are our print modules. One would always print to wax, like I mentioned. The others have different types of materials that are depositing onto the plate. That's not a full build. The full build is over there on the table, but this is kind of a partial size. As you can see, everything's coated in wax. It's dipped into a tank. I mean, this is all a batch process. A particular build can have, I don't know, 300 parts from 20 different customers across 6 different orders. So it's all in one basket. So it's a batch process. Wax is melted away, and then the parts themselves go to a cleaning step to de-wax and then to degrease the parts, and then they're rerouted to different bins, to different boxes, and to different customers. So it's a very unique setup that we have. In fact, kind of a tough process hurdle for us to get past. Not too many softwares out there that can handle taking a particular order, collecting a ton of different ones across different plates and different sets across different printers, and then collecting them again and then getting them out the door. It's a tough little dance that we have to manage, basically.
I think on that, maybe we can jump to like your evaluation criteria, because just on the point, like when you were thinking about like digitization and like starting to evaluate, like you have these different production lines, but even like within like the lines that you have, they are like distinct to your business.
Absolutely, and so each one has a different operational hurdle, obviously, but the reality is that they all scale differently too. They're all have different customers, right? So our machine manufacturing, let's just say, component of our operation is not going to have nearly the same kind of processing or even the same customers as our service bureau printing service, because the people who are buying parts that we print for them are not the same people who are buying printers. So we have to make sure that the process that we set up is essentially built for that particular leg of our operation, is scalable, but it's not necessarily kind of a one-size-fits-all across all the different business lines. So for example, for our machine manufacturing, we are a kind of a cell-based manufacturing approach. So it's not really a production line or anything like that. So it's all kind of driven by a very modular printer. And so, at least from a Tulip perspective, we're leveraging Tulip to trigger the assembler to say, okay, we've got to build a machine. Here are all your assemblies. This is your step 1. You click through your step 1. Here are your work instructions, and then it guides the assembler from there. Not that it tells them how to assemble. We still need skilled trades. We still need a ton of folks who know what they're doing, and that's Gene Arnold talked about that in this morning's presentation. So we still need to make sure that we hire the right folks, but it's all about triggering and timing and making sure that we don't have waste, and it's all about process efficiency, not about substituting people, but just augmenting, leveraging them a little bit. From our service bureau side, that's a little bit more complex, just because of the nature of how we process parts. So we have an integration with HubSpot, so our commercial, it's not even a front end, what our commercial uses is HubSpot to be able to manage customer information, customer data, orders, and things like that, integrated with Tulip. And then our Tulip software basically aggregates orders so that we leverage the efficiency of our process. If we processed each order just as it came in and then process it through the printer, we would be losing a ton of cash and we'd be losing a ton of customers. when we talk about throughput for our machinery, it's got to be scaled, right? We've got to have a ton of parts on a particular build, and that's how we leverage our process. So we need a system, we need a software that takes all the different orders, all the different types of parts, packages them very efficiently on a single build plate, process through in a batch, and then splits them off again. That was quite a big hurdle. That is the scalable piece that could have hurt us and could have killed us.
Can you double click on that? It was helpful, I think, in the last session you explained like where the like integrations and apps lived when the order went through, and like how it included the operator, or like gave the alerts to the operator of like when the part was ready for their use.
Yeah, I think scalability is important, but I think the most important, even more important than that, when we talk about what can kill you, what can't kill you, if the operator doesn't quite know what to do when, then that is going to tank the order. And given that we're a startup, and it's not like we have a ton of cash, it's not like we have a ton of customers, people, we have to be very, very careful with our resources and our money. If we lose a few days because the operator just is losing parts or doesn't know what to do, that can actually kill us because parts aren't going out the door. So we need to make sure that we take a bottom-up approach to make sure that the person knows exactly what they're doing and exactly when they have to do it. Tulip we developed and customized because there is no ERP that we could have chosen off the shelf that was even reasonable cost to be able to do everything that we need to do at this kind of complexity. So we built our own, right? So we leveraged Tulip to be able to say, okay, what can kill us? What's our metric that we need to hit? That's really, if you're just building an application just to do activities, it's probably not going to be as effective as if you're actually using it to pursue a particular goal. And our goal was, we know if we can get product out the door, that's going to actually close our doors. We need to start getting revenue into our bank account. So what's our turnaround time and what's our dwell time in our process? That was the most important metric that we knew that we had to hit. And so we developed our Tulip process to be able to say, okay, printer tech, here's the aggregate of all the orders that came in from HubSpot today. Plate them and put them on this particular printer. So, okay, plated, used our construct software to fit everything together as efficiently as possible. Tulip, the operator says, okay, cool, all of these are plated, check. Tulip is now telling them, excellent, put it on this printer, clock starts now, and then the operator puts it into the printer. Then Tulip will email the operator, because we have full integration with the printer natively. Tulip says, the printer is done, all these orders are done, start your post-processing. Step one, go to this particular wax melt bath, and the clock starts now. So the clock starts, the operator is emailed saying, pull these particular orders off of this particular printer and put them in this particular bath. Go, do that, put that into the bath. Tulip knows, based on time, that, okay, that's done. The operator confirmed when he put it into the bath that I just did that step. And it knows, okay, next step, hey, time to move it to the de-waxing solution, time to move it to the degreasing solution. So we really push to make sure that the operator is being triggered and not the other way around. Tribal knowledge is important in a startup, it's important at any company, but you have to work to try to get around it or reduce it, right? Because the more you rely on tribal knowledge, the less efficient your business, but then also production can stop, if you're just relying on one person or whatever. So processes are important, and that dictates scalability. As a startup, no, please.
Can I ask you a question?
Sure.
What if an operator misses a step? I mean, does that screw the whole process up within Tulip, or?
It doesn't screw it up in Tulip. It might be a real bummer for the actual parts themselves. For example, our parts need to cure, right? So 3D printing, we have our process utilizes photo-initiated resins, so there's a UV lamp inside the printer to cure the parts, but they're not 100% cured. So some of the process after printing is used to also finish curing the parts. If they're left too long in a particular bath, the parts can be ruined.
Right, but what I meant is, they don't screw up the process, but they screw up
Absolutely
punching
not.
the buttons and say, I took it out of the bath, or I did this or that.
Absolutely. So if they don't press the button that is moved out of the bath, that actually then will it throws a flag. And actually we have it integrated into a dashboard, and we use Grafana as our kind of a visualizing kind of software. Grafana, yeah, it's and that is integrated with Tulip is actually fantastic because it just has essentially tables. So it'll just call the table and say, okay, it's in this process and at this step, and X amount of time has gone by. Oh, the operator didn't confirm that it was, that next step was done. Here's a flag in the dashboard, done. So mistakes can still happen, and you still need training, and you still need all this, Kanban and Kaizen and all these different things have to work in concert together, honestly. But yeah, so there's nothing that screws up in Tulip, if anything. Tulip is working exactly as it should, because it's then flagging our visualizing software, says this is an issue, it's showing as a fault, that corrects the operator, or it actually tells our QC, head of QC, we've got a problem here, let's look into this. And then is it a process issue? Is it because the operator is too busy and you didn't see the email? Should it not be an email? Should it be some sort of other kind of, maybe we have to integrate like an and-on system, maybe on the factory floor, which we're not at that level yet of kind of visualizing, but maybe that's the solution. So no, nothing, as long as you set up Tulip properly, then no, it won't screw it up.
Can you talk a little bit about the time and the integration process of Inkbit with Tulip and how that works?
Yeah, so Tulip itself is fully customizable, and the only reason we went with Tulip is because it was so customizable. We didn't really have much of another choice with respect to software. It just was sort of a no-brainer. But you're talking about the actual modules themselves, right? Like
Because you said it's a homegrown ERP system, right? So
correct. So it's all with what you make of it, and I don't know if I'm going to answer your question exactly, but the approach that we took was this has to be bottom up. So the people who created the, maybe not doing the exact button clicking, but the person who created, this is what I want to see in a trigger process within Tulip, was the printer technician. They mapped it out, maybe with some help from our operations engineer, but they mapped it out, and then the operations engineer basically put together this app, implemented it at the workstation where the print tech frequents, and then go ahead and try it out. Maybe it took about 8 hours if you like dumb it down, but that's based on what we wanted to build. It took about 8 hours. Maybe you can build something in an hour that's pretty straightforward based on the metric that you're trying to achieve. It's all very much driven on what task, what the activity is, and what the output is that you want. What do you want to know from it? For us, we've culled it or kind of like sussed our process out such that we know that if we need to build out a new module, it's probably going to take us maybe anywhere from 8 to 16 hours. And then testing might be another week, and then that's just kind of the cadence that we got into because it's appropriate for how we like to roll things out and what our processes need. But really, you can turn that into kind of even smaller bites if you really wanted it to. It's just sort of that's just how it happened for us. So I don't know if that kind of was going down the path that you were.
Yeah, it was just interested in the process because we're not using Tulip, but we're looking at it. So just wanted to know that flow.
Yeah, and the reality is that this is it's not really coding, right? So as far as Tulip goes, and I certainly don't want to take over
I can
for
help with, yeah.
But it's a table-based process and can be integrated pretty easily. So we also leverage Power BI for certain kind of I guess data analysis needs that we have. Tulip is good for activity-based processes, but that needs to be fed into something else if you want to maybe have fun with the data, right? Then there are other tools that are appropriately built and made to be able to kind of mess around with it. Yeah.
Yeah, so I would add the way that the Inkbit team is using it, like it solved like their need for an ERP and also extended into like process management and order tracking and some of the other I think like component parts. And then the software itself is like an app-based operations platform. You can do processes through like automations that are like no front-end piece, but Tulip is really like the platform that helps configure the connections and like the connections to machines and other softwares. You could do that through connectors in the platform, so like either through protocols or HTML or SQL connectors, and the time to kind of implementation to Filip's point depends on like how many component parts of your system you're trying to get out at one time. So if you're like, most people start small and kind of scale up so that you're kind of like rapidly seeing like first critical value and then expanding your system versus trying to define all requirements at once. And something like an 8-hour investment in building your first app is normal, and you would like iterate and expand on that by plugging in different pieces to that system that you're building out.
Okay.
So I'm curious about approximately how much productivity improvements did you see by adding Tulip to your workflow process?
Excellent question, and in fact, I think you mentioned something in your chat how it was difficult to get a dollar figure number to be able to say, hey, this is the improvement.
Right.
But the example you gave is something that triggered a memory for me. You mentioned that you can see their OEE data. You can see the progression there. I don't know if this is like a funny anecdote. It's actually a painful one. But we were actually every company meeting, our OEE progress was displayed on our company slides. Here's where we are. These are the metrics that we're using, and this is how healthy we are. And it looked fantastic. This is pretty sweet. But we have a trash can full of customer parts that failed inspection. Like, what? This doesn't make any sense. And the issue wasn't with us, like the OEE calculation. The issue was the different variables within the OEE. We just hadn't defined properly, and we weren't making sure that we chase some of the loose ends and that they're measuring from the right point. Yeah, okay, we're measuring a part failure, but is the part failure because the material properties are an issue, or is it because the printer, from a hardware perspective, just didn't act appropriately? We had to get to the bottom of the different components of that OEE calculation to be able to make it useful. And so we have not yet gone back to, here's the display of our OEE, but I can tell you we've hit some serious strides, because our maintenance has gone from us hand scraping the machine every hour to the machine running a self-maintenance cycle before and after every print. Done. And then, as far as customer part failures, Filip is capturing very granular detail on where and what failures they are, because we have a ton of different failure modes. And we're going to use that to say, okay, do we need to change the print process? Is it a material property thing? Then we know. Then we know that, at least from a quality control perspective, that component of what we're calculating for OEE is under control. That's reliable now. Our uptime we've worked on in parallel, so we know that that's a reliable. So we're almost to the point where this equation is actually going to be pretty healthy, and I think we'll be able to start using OEE, like true OEE data, to be able to guide us and whether or not we're actually doing a good enough job with our process efficiency. So we're not. I don't want to get ahead of ourselves and say, yeah, we're super efficient. We don't have a metric that really says that yet. I think OEE will be that, but we're just not there yet.
What's your gut feel is that you're gonna see those numbers and it'd be significant or worthwhile?
Yeah, and I think one important indicator, and this is really difficult to quantify, is I guess employee stress. Right, so our printer technician is stressed for other reasons, right? So volume of sales orders, it's taken off. We've posted for another printer tech just to get some help in there, but the stress isn't related to the work itself, or this doesn't make any sense, or something's not working, or this is inefficient. It's related to, we got a ton of work, we just need some more people here now, because we're growing at 100-something% quarter on quarter. We just need more help. So stress is down from that perspective, and I think that is an important indicator. It's not quantifiable, but I think that's an important indicator.
I just have another question.
Sure.
Is it the stuff intrigues me, 3D printing?
Yeah.
Flexible 3D printing is
That's
interesting.
wild. I didn't even know that was possible until I started Inkbit.
But how strong are products produced by 3D printing? Like, you wouldn't use it on a machine gear, would you? Or
There was a fascinating conversation with someone at the previous session at the end, where there's a real problem with folks sometimes seeing 3D printing as metal replacement, and that's not a healthy way to look at it, right? Because metal replacement is a very singular, like, oh, instead of metal, let's just make it out of plastic. And then the expectation is that plastic has the same material properties as metal, which is impossible. No material has the same material properties as something else, because then it would just be that material. Logically it doesn't make any sense. So what you have to do is, when you look at creating a plastic part, a 3D printed part, and you're like, you know what, I want to do metal replacement. It's not really metal replacement. It's a holistic, different point of view on design. And Andre, feel free to correct me if I'm like kind of going off the rails here, but if you can stomach thinking about part design differently, and what the application is actually trying to achieve, instead of just doing a one-for-one replacement, then you can potentially start leveraging the material properties that are better with this versus metal, for example. It all depends on the application. So no, I mean our epoxies, I would not use those as kind of load-bearing gears. Like, I wouldn't put that on my motorcycle, that's for sure. But there are other applications, and like fluidics pumps, microfluidics and things like that. That is an appropriate application for sure, and that takes assembly. Maybe the loads aren't, we can't handle certain loads, but we can handle certain pressures and things like that, and certain chemical compatibility and whatnot. And that's a more appropriate application. So it depends on design approach, right?
Yeah, I mean, I can speak to this too. I'm our senior mechanical engineer. So I mean, we are.
Let me suffer through all that.
We are very comfortable using our technology to build our technology. So there's probably somewhere in the order of 50 parts in our machine that we print on our machine. Partially, it's the convenience of it. There's some parts where if we were making 100 or 1,000 machines a year, we would injection mold those parts instead. But at low volumes, the tooling is wildly expensive, and we already own the machines and get the material for the cheapest possible price. Anyone can get the material. But there's different designs constraints. So sometimes your constraints are stress or load based, right? It's how this part is going to see a very heavy load in its use. Other times, and that's very difficult for us, right? We make resins which are very good as far as 3D printing materials go. 3D printing materials across the board generally perform worse than injection molded plastics. It's just, we can go into a lot of detail about that, but it's sort of an artifact of how the chemistry works. But then there are other designs which are what I would describe as form constrained, right? So you need something to be a particular shape, but the strength isn't as much of a concern. So fluidics is a great example of this. You need all of these tubes to move material from point A to point B. Maybe there's some mixing that needs to be involved. There's a lot of complex mating involved. But it's not like, this little bit of water that you're flowing through a pipe is exerting a huge pressure that's going to break your whole part. So in a situation like that, then 3D printing becomes way better because, we've had parts or customer parts or internal parts where you have a manifold where you're drilling 80 holes and plugging 78 of them, right? So you can just do this very complex circuitous path. And then we end up doing something that works better because the form can more accurately do what you want it to do, and you aren't sort of doing a bunch of operations and then trying to undo half of them. And so we end up with something that is better performing and cheaper, which is just a very easy sell.
Thanks, Steve.
Switching gears just a little bit, unless there's anything to interrupt, so you've worked in two very different manufacturing companies, cultures, and environments, both where you had an opportunity to kind of see types of digital initiative roll out. Can you describe the difference culturally and really the principles or things that you all are thinking about at Inkbit culturally as you continue your journey scaling your updated processes?
And it's very easy to kind of say, because I was at a traditional manufacturer, and it's easy to say, well, at a traditional manufacturer was a little bit more resistance to change and that sort of thing. And at a startup, it's really easy and whatever, man. The reality is that everyone is bringing their own thing to the table, right? So at a startup, okay, yes, I would say in kind of a very high level, it's a little bit easier to start implementing something, but you're starting from no process. So it's easier in that sense that you're starting from no process to implement a process, but you still have a ton of folks who are from different industries and coming from different areas, bring their own experiences, bring their good habits, their bad habits, myself included. A lot of learnings that they have. So you still have to get past that hurdle. Folks still have an opinion, a valid one, and it's healthy to have that, and it's important to have that because you want buy-in from stakeholders. And a more traditional manufacturer, at least in my experience, the issue is more so we had processes that worked. I'm not saying that they were scalable. There were promises of, well, we want to make sure that we can accommodate more revenues, but if folks don't feel that we're necessarily going to achieve that, what's the point of implementing an ERP? And that was the big hurdle that at my last company, implementing an ERP, convincing folks that this is necessary because we don't need it to scale necessarily. We just need it for efficiency's sake. And when you don't have real data to be able to convince folks, and you need an ERP or something that aggregates the data to show that, it's sort of a catch-22. So that was a tough thing to actually kind of get through. At a startup, it's a little bit easier, like I mentioned. but you still need a mindset and a culture to be able to accommodate this. Okay, and Arnold, you talked about this, and I loved it this morning, which is you want to make sure that folks have the mindset. There's got to be a company culture to accommodate smart manufacturing, data, whatever. People have to be receptive to it. If you don't sell it, if you don't see the value, even if you have metrics that show like, hey, we need to make sure that we measure this, you need people to buy in. And if the CEO and executive leadership don't create that kind of environment and that culture for folks to be able to be receptive to new ideas or to kind of take a different approach to the next step, you're going to be fighting an uphill battle. So it's not an operations thing that I have to overcome or we have to overcome. It's a company-wide thing. It's a company-wide mindset. And there was one question at our previous session. Well, how do you communicate? Well, part of it is dictated by what the culture of the company is. We're lucky at Inkbit because our CEO is very transparent, and everyone at Inkbit knows the financials, and we know what the direction the company's heading, and we know our health. So it's not weird if I kind of display for everyone, here are the pains for our printer techs, the genuine pains. This is the problems that they're having. Yes, we can solve this by having somebody else do it, but that's just kicking the can down the road. Like this is what we're trying to get. So it's an open, here's what's going on in operations, here are the pains that we're having, this is how we're trying to resolve it. Upstream and downstream, are you folks cool with this? Like do you buy, even if it doesn't affect their day-to-day, are you cool with it? Can you appreciate that if whatever you put in, this is the effect that you have on us? It's a conversation at Inkbit. Maybe it isn't at other companies, but for us, that's kind of what the approach is. And there was another, I thought there was another comment about kind of metrics and things like that. And I don't know how if we got into that, but that also dictates what that conversation is like. Right, so if everybody understands, like at a start, like what can kill us, right? If that's the question, you have to answer that question. Every functional group or department might have a different answer. But if everyone agrees, yes, that can kill us. Okay, I've got an idea on how we can solve this. Cool. Then let's follow this idea. Let's see if we can make it happen. If you're just blunt with it, then I think this will stop us. I think folks will listen.
Conversation is like always centered around like the needs of the business, how the business is doing, and like rooted like we're making this change because this metric or just tied to this thing that's important for the business.
Right, and as logical as an explanation or a reason can be, that doesn't necessarily mean it's going to be accepted. I would love that for that to be the case, but that's not necessarily true. But then also, at least from a tulip perspective, it's kind of nice because it's also, from an operations perspective, we, to a certain degree, control our own destiny. All right, if folks aren't going to accommodate us, or if we can't convince them, we're going to build something out that accommodates how they want to input work, and then that synthesizes it to how we're going to operate and how it's efficient for us, which is kind of how we built Tulip. Sales just has to worry about sales. We haven't built that out yet. We don't have a front end just yet on accommodating quotes and things like that. So just feed us the orders. We'll organize it. We'll do everything. Just get it to us, and you worry about the important stuff like selling. So there's that component of it too.
Does anyone else have any questions for Filip? What challenges do you kind of foresee having to navigate in the next 6 months, year, 2 years as the business grows?
So scalability is very important, right? So individual heroics are always very, very important at a startup, but also have their place, right, in a mature organization too. But people will burn out. People will get tired. The landscape might change. Maybe the financial situation changes. That increases stresses. Maybe that changes how people are motivated or whatever. You have to, in order to survive, be able to try to get away from those individual heroics. And so scalability then comes into play. Flexibility, scalability, I've said a few times, they're not perfect reciprocals, right? They're not perfect inverses of each other, but they're pretty darn close. And if you want to be 100% flexible, you're not going to be able to grow in a I guess predictable manner, right? That's a component of scalability. You have to be able to say, okay, this is how we're going to grow, and this is that. But if you immediately pivot a different revenue stream, a different customer, maybe a different way of doing things, that's just not going to work necessarily. Our priority now is going from tech startup to technical sales organization. That's our big journey now, and that means pivoting from flexibility and having a higher priority on scalability. And that higher priority on scalability is going to be different if we're trying to push a machine out the door or if we're trying to get parts out the door through a service bureau. And right now, because we're treating the service bureau as sort of a conduit for potential machine sales or JDAs or partnerships or whatever, we've prioritized our service bureau, which means we've prioritized all the Tulip apps and all the integrations and everything else to be able to process orders in a smooth way. And we think that's actually going to bring us to success, right? We've seen great growth in the service bureau area, but scalability is the operating word now, right? Technical sales organization, scalability. I think we've built that. We just have to get that revenue.
I have just a couple minutes left. So one question I have for you, just on closing thoughts, is if you were going to like either go back in time and give yourself advice or like just give pointers of like things to keep in mind when you're starting a digitization journey, like what would those be?
It's not going to work if the culture isn't there. In fact, that's probably the most painful part, because you can get a ton of smart people. They can create a ton of cool apps and triggers and functionality and all that sort of stuff, but the culture isn't there. It's sort of kind of a moot point, because the moment you stop pushing, folks aren't going to use it, or they're just going to let go of the reins or whatever. It's got to be a top-down approach. Building things out, when you talk about actual tactile like steps and things like that, you do the culture a favor by leveraging and enabling folks on the front lines to be able to create the process, to build out the applications, to talk about what the triggers that they need or how they do the work. You're actually going to probably strengthen the culture, if anything, because they feel like they have a stock in what's going on. But management needs to set that up. Executive leadership needs to provide that kind of ecosystem for people to feel like, yes, they can safely say this is what I think should be done, but then also feel like they're motivated to continue working because there is a specific goal. They see the goal line. They know which way they have to run. So most of it is cultural, which is hard to quantify, I think.
Well, thank you so much. Also, thank you guys for like the last
Yeah, really
session
appreciate
before
it.
lunch, which I know is always the toughest one. I
Yeah.
appreciate the engagement.
Yeah, thanks very much for your time. Really appreciate it.
Thank you.